So we're in section 12.3, and this is to do with measures of dispersion. So that means we're calculating standard deviations and such. So we're going to do 3 and 9, which are just basically the standard calculations. We're going to do this by hand, even though we could do it by the calculator. And we're asked to find the range and the standard deviation. So problem 3 has, looks like about 7 numbers, right? And they're already in order. They don't have to be in order, but they are. So the range is always the largest value minus the smallest value. So the range is 13. So that's one measure of dispersion. The second measure of dispersion is the standard deviation. And we've done this a couple of times in class, but we'll get some more practice here. So remember, we create this table that's 3 columns, and it has to be really should be 2 more rows than the number of data points. So I'm going to make 2 little tables and stick them together. Because we need the last row for the summation, and we need the first row for the heading. So we have the data, we have the deviations, and we have the deviations squared. So our data is the first column, so we just write down the numbers. And again, we don't have to do them in numerical order, but that's already the way they've done it, set up, so I might as well take advantage of that. And we'll also be able to. Did I make too many? Did I miss something here? 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. I must have made an extra row. I don't know why I did that. Anyway, it doesn't matter. I don't need to use the last row. So just get rid of that. So here what we need is the mean, which is a measure of central tendency. And all you do is you add the numbers together, the values together, and you divide by the number of values. So we have 7 values, and so 2 plus 5 plus 6 plus 8 plus 9 plus 11 plus 15 is 56, and divide by 7 numbers, and the mean is an 8. So that's the mean. It's also the median. If you think about we have an odd number of data points, 7. Divide 7 by 2, you get 3.5. You round up 3.5 to 4. The 4th data point is the median. There's no mode because they're all different. Okay, the deviation is this number minus that number. So the deviation is how many below the mean is each one of the data points. So you're going to take 2 minus 8, which is negative 6, 5 minus 8, which is negative 3, 6 minus 8, which is negative 2, 8 minus 8, which is 0, 9 minus 8, 1, 11 minus 8, which is 3, 15 minus 8, which is 7. And if we add these deviations together, we should get 0 if we've done everything right. So negative 6, negative 9, negative 11, negative 10, negative 7, 0. So if we add all those up, we get 0. Then we square the numbers. So these are going to be either perfect squares. So, and the negatives become positives. So 6 times 6 is 36, 3 times 3 is 9, 2 times 2 is 4, 0, 1, 9, 49. 7 times 7 is 49. We add those up. We use the sigma to represent that. 36 plus 9 plus 4 plus 0 plus 1 plus 9 plus 49 is 108. So the standard deviation is defined as the summation of the deviations squared, which is what we have here, and then we take the square root of that whole thing divided by n minus 1. N is the number of data points. So the numerator of this calculation is 108. The denominator is 7 minus 1, 7 data points. We take the square root of that. So it's the square root of 108 divided by 6, square root of 18. The square root of 18 is 4.24. So the standard deviation is 4.24. The range is 13. Okay. So we did that for 9 now. So we have a few more data points with a few more decimals. So so how do you find the range? Well, you got to identify which is the largest, and are they in numerical order? They're not. So we're just going to have to look for the smallest number and the largest number. So since the range is largest minus smallest, let's look for the largest. So I see some 85s. There are two 85s, and the highest 85 is 85.62. And then I look for the smallest number. There are no 83, so it's 84. And we look for the smallest 84, which is 84.48. We take that difference, 85.62 minus 84.48, and so our range is 1.14. Now the second, so that's part A. Part B is the standard deviation. And I just want to be clear, if you don't show these tables on your homework, I'm going to give you 0 credit. So don't try to get away with thinking you'll get partial credit. I'm getting a little annoyed about that. So, sorry. Anyway, how many data points do we have? We have 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. So we have 9 data points, so we need So we need 11 rows. So I think I'll just make it 6 by 3 and just make 2 of these. I'll have that 1 extra row, but it's okay. Okay, so there we go. There we're in the first column, data. Second column, deviation. Third column, deviation squared. Okay, so let's write down the data. Again, I don't have to put it in numerical order if I don't want to. It's hard when you have this many decimals to, it's not super hard, but it's not as easy as with a 2 decimal number. So this could be something like temperature, very accurate temperature measurement. And I should have 9 numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so we need a mean. So we're going to add all those numbers up and divide by 9. 84.96 plus 84.60 plus 84.58 plus, I forgot one here, 84 point. Yeah, I did 5, no, that's right. 84.58, 84.48, 84.72, 85.62, 85.03, 85.1, 84.53. I get 700. No, that's right. And divide by 9. And I guess you get 84 or 85 since all the numbers are 80. The value is 84.85. Okay, so that's the mean. So now we're going to take these numbers and subtract that number. So go ahead and do this, do it in your calculator as I'm doing it. And so this number is greater. So I should get a positive number there. Next one's smaller, so I should get a negative number. Okay, so those are all my deviations. Now if I add those together, I can check to make sure that I didn't make any mistakes. It's not as obvious in this case, so you got to be a little more careful. So I didn't get exactly 0, so I may go back and, well, first I'm going to check my numbers. So I'm just going to look at this and do it in my head. And there shouldn't be any rounding errors, so okay. So I got this one was wrong. So let's try it again. So just adding column 2. Still getting something wrong. Let me just pause it for a second. It's not. Okay, I don't want to get exactly 0, but I think it's just a rounding issue. So I'm going to assume it's okay. Okay, so now what we do is we square these, and they're going to be reasonably small. And these all end up being positive, because anything squared is going to be positive. Now you add them all up. So hopefully you're doing this instead of just waiting for me to do it. So I'm giving you as you work along. And you can always stop if I finish before you do. You can stop the recording. And then just wait until you're finished and then check your answers against my answers. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. Just checking the numbers. And so the summation becomes 1.0915. And so the standard deviation is equal to the square root of the summation of x minus x bar squared over n minus 1. So we already know what the numerator is. That's 1.0915. And we have 9 data points, so we take 9 minus 1, which is 8. So we take 1.095 divided by 8. So we get the square root of 0.1364. And the square root of that is 0.369. Okay, so we'll stop on that one and continue on with the new video.